Hey, welcome back to our shop. This is part 2 on the compact rotary brooch I'm building off a Heminway kit. And right now I'm kind of boring the mounting holes that hold the body to the shank. And I had to regrind. I took a 6mm drill bit, standard twist drill, and I ground a step on the end and I resharpened the cutting edges with my die grinder with a small cutoff wheel. So I have a piloted counterbore with 6mm major diameter and 3.5mm minor diameter. I don't have such a counterbore. I don't even think such a thing exists. Normally they have 6.5mm outer diameter and a smaller pilot. But there is no space for a bigger counterbore diameter, so I had to regrind the drill bit. Another way to do it would have been to use a 6mm end mill and plunge down, but I would have to indicate each hole by itself, and I think that's faster. And I'm holding the part just in a 3/4 chuck, and that's sliding freely on the table, so it can align with the pilot on the counterbore. A little bit of cutting oil, and we're good to go. Okay, works a treat. And while I'm freehanding at the milling machine, a quick safety tip. Whatever you do on the milling machine, if you hold a part freehand, that also is viable on the drill press. Never, 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 never prop your fingers in the T-slots when you hold a part. Like this, propping a finger in a T-slot. With a round part it's not as bad, but if you have a vise or something like that and you try to hold it and you prop your finger and you get a catch, the vise will swing around and shear your finger off flush to the table. Because you get a nice guillotine action between the table and your part. So don't ever do that. Never prop your fingers in the T-slots. Ugh. And as you can see, this one over here is already done. It's finished. And this one still needs some work. What I have done, I aligned it. The two parts are split here. This is the split line, and you can align them side to side following this key we machined in. And you need to align them so if you have a brooch in there, that the end of the brooch runs through. And I set that just on the lathe with an indicator, and I will show you that in a second. And after we have set that to center, we will take out one screw, add Loctite, screw it in, and do the other screw too, so it's locked permanently. There is no need to adjust this later. As long as you make all the brooches to the same length, that's not a problem. This is the first brooch I made. This is a 4mm hex, almost 4mm. I just roughed this out of a piece of high-speed steel to get a first test running, and it works quite well. And after I have set the split line correct and locked it in place, I can machine the outer diameter of the brooch down so the alignment surfaces here vanish, and it gets a nice and neat package. I will also engrave into them the length of the punch that has to be used with them. So if I have to make a punch for a brooch for this guy in 5 years from now and I don't have the drawing around, I just I have the measurement readily available on the tool. So that's also another thing to do. And of course we will make a bunch of these brooches. I want the complete set of hex brooches from 2 to 6 millimeters across the flats. I clamped the rotary brooch in the collet chuck, and I left enough space here between the rear face of the shank and the collet so I can take a hex wrench and tighten the screws that hold the shank and the tool together. And the whole reason for this whole exercise is to align the tool itself on the shank. When I spin the chuck, you see all sorts of run out. As the tool itself is angled by 1 degree, it has this weird motion, this weird run out. And I have a tool with 8mm diameter clamped in the tool. It's in the body or in the spindle of the brooch, and I have my indicator tip at the position where normally the rotary brooch would be ending. The face of the rotary brooch would be at this position. As you can see, this is roughly the face of the tool is roughly in line with the tip of the dial test indicator. And when we spin the spindle, we get a run out up here on the indicator. And we want that run out to be as small as possible. And I will do that with a hammer and by semi-tightening the screws so I can bump the body of the tool around. And now I need to deburr the cross hole here. That's typical scraper work, hand scraper or three-sided scraper, which is in this case, this is an old needle file that I hardened on the end, did not anneal it, and then I ground it like a scraper. Okay, I got a very useful tip a few days ago. The lure lock hypodermic needles that you use for solder dispensing and also for medical syringes, they fit without any modifications on the tip of a Loctite bottle. Also on the big Loctite bottles, this one. Goes on without the modification, and that's a very useful thing if you have, because the original nozzle of the bottle is not very precise, to speak friendly. And I got a whole assortment of these lure lock hypodermic needles. Those are without a sharpened tip. I also have sharpened one. These are medical needles. These will go through flesh without a problem, and you have to be careful with those. It hurts like it hurts like crazy if you get puncture with those. And also you don't want to get Loctite thread locker under your skin. So let's take out the first screw. I do not remove both screws. Get some thread locker on there and drop them back in place. This is just so nobody does accidentally change the setting of the offset setting of this tool. So it doesn't hurt to Loctite them down so they are fixed in position. And this is just a Loctite 270 high strength thread locker, not the 648 bushing glue that holds everything until the end of days. Flushing the needle out with some isopropane alcohol and some compressed air. Okay, I have taken apart both of the rotary broaches, cleaned them out from eventual chips that got in there during the machining process of the outer shape, and also getting rid of any grit from sanding it and polishing it. So I took them apart and I rinsed everything with isopropane alcohol. Then I used some grease on the open bearing, the axial bearing, looped it up with a reasonable amount of grease and put them together, back together. In the process of reassembling them, I sheared off one of the pins of this face spanner. This is one of the adjustable types with the pins that you can set to the desired distance, and this is one with 1.5mm pins, and those pins are not hardened. It sheared straight off. So I made a proper face spanner with 1.5mm hardened dowel pins, and this is more than adequate. Probably slightly overkill, but this will last me a lifetime if I ever need a 1.5mm face spanner with 14mm pin distance again. So what we need now are tools or broaches, and I have one here. That's the one we used in the last video for the test run. 8mm high-speed steel, and I ground a 4mm, roughly 4mm hex onto it using the single lip cutter grinder. And I want to make a complete set of these broaches from 3mm up to 6mm. I just took a look at the 2.2mm broach, and this looks awfully small, but I will give it a try too. 2mm and 2.5. But for now we will start with 3, 4, 5 and 6mm. I have some high quality 8mm high speed steel. This is cobalt 10% cobalt grade high speed steel, and this is the real deal. We will cut off length of 28mm with the cut-off wheel on the surface grinder, because that's the fastest way to cut high-speed steel that I know. It's even faster than with the angle grinder. For some reason the the cut-off wheels for the surface grinder cut way more aggressive in high-speed steel than an angle grinder wheel. So let's go over to the grinder and cut off some pieces. Okay, I already ground two of the hex punches. This is a 6mm hex and this is a 5mm hex. So next we'll grind a 4mm and a 3mm one. First I need to dress the grinding wheel. And now we set the depth or the length of the hex section that we're going to grind by adjusting the infeed like this. And I want about this length. Now we're roughing out the hex. And that's 4mm plus a little bit, and that's I would even prefer it a bit more oversized, because I think when you machine a hole with the rotary broach it tends to get smaller, slightly smaller than the punch, because of the elasticity in the material itself. But for now this is good enough. I have to get some experience with the rotary broach first, because before I can do more tooling for them. I ground broaches from 2mm up to 6mm. For the beginning I only made one set because I'm out of 8mm high-speed steel stock. I first need to order a new one. I have the two rotary broaches finished, and also I have the key that I possibly never need again. Okay, we're over at the milling machine, and I have a piece of angle iron hot rolled in the vise, 3mm thickness, and I pre-drilled with a 5mm drill, and now we're going to broach a 5mm hex into it. Some cutting oil helps, that's for sure. Then we get it in contact, and now we have a chance to align the orientation of our hex just by spinning it in the orientation we want and bringing it into contact with the workpiece, and give some pressure on the quill. Then we turn on the machine. I have it set to 1000 RPM. There we go. It takes its time. You will feel that it takes a little bit of pressure on the quill, but as the angle of the rotary broach itself is only 1 degree, the chip it takes on each corner for each revolution is quite small. Let's see, I have a 5mm hex key here, and this is, oh yeah, this is a very nice fit. I will do the second one, and then I'm going to bring the camera in. Bring it in contact, give it some RPM. I think the pre-drilled hole could almost be a little bit smaller. There is still some round section from the drill bit left that can be seen. But apart from that, doesn't look too shabby. Also, I'm of course lacking experience with such a tool completely. This is pretty much the first time I'm using something like this. I don't think that this tool is something for super high precision applications, but to get a hex in to drive something with an Allen key, that's the right thing to go. Or if you want a square hole for a carriage bolt, that's your tool to go. And here you can see the back side of the test piece. We don't get a whole lot of burr, so that's reasonable on a through hole. With a blind hole you get, of course, the chips collected at the bottom. Okay, now we're over at the lathe, and I have the 6mm hex punch in one of the rotary broaches and pre-drilled 6mm. So let's try this. Get some cutting oil on there. Get it in contact and give it some RPM. And I push the work into the collet. Helps if you clamp your workpiece properly. Do this. Bend over one of the ends of the chuck key. So the hex started to form, but then the force needed to push the chip down into the hole got too big, and the workpiece got pushed down into the collet. And that's not good for a workpiece or your collet. Okay, let's see if we can engage in the existing hex again. Okay, there we go. Got it back engaged. Okay, a 6mm hex in steel definitely takes a lot of axial force. That's not something I would do on this lathe all day long, but the hex came out spectacular. You can see that the chips piled up on the bottom of the hole completely, and I think to go deeper I would have to remove the chips with a drill bit and then come back with the rotary broach. But man, that's a good result. That's a proper hex, and it even fits my this thing, you know, Imbusschlüssel. Fits quite nice. Doesn't rock much. The surface finish on the side walls is quite impressive for such a almost brutal tool, because it's pushing away the material. So I'm very happy with the results. 5mm hex in steel, 4mm hex in steel, both on the lathe, the 5mm hex on the milling machine in steel, all not a problem at all. So okay, I took the rotary broaches and I engraved my initials, the year of make, and L0 28mm. That's the length of the punches of the or the broaches. So without having the documentation to this tool at hand, I always know, or the person who gets the second one of these always knows, that the punch has to be 28mm long and to tip. So that's helpful. I blackened them this time using cold blue. After engraving, I dabbed on some cold bluing, waited until it reacted and I got a black color, and then I removed the excess with some fine Scotch-Brite, and it worked out quite well. I like it. Seems to be very durable, of course, because the cold blue finish gives oxide layer or something, and this should be very resistant against oil and solvents. So I hope you enjoyed this project. This will be a rather handy tool, and I'm pretty sure that you will see it in the future in another upcoming project. I have a second Heminway kit that I'm going to build. So thank you all for watching and see you next time.